In section 1.2, we'll be dealing with quadratic equations. These are different than in section 1.1, where we were dealing with linear equations. Recall, back to section 1.1, a linear equation had the form of something like 2x plus 7 equals 13. Notice the x in this equation is to the first power. A linear equation will have x's to the first power. Anything to the first power will always have one and only one solution. It actually can have less than one. It could have no solution at all if it wasn't in the domain, but at most, the maximum number of solutions can only be one in order to match the degree of the polynomial. So in section 1.2, we're dealing with quadratic equations. Quadratic equations are of this form where x is squared. So you can see that the degree of a quadratic is 2. When the degree is 2, you might have up to a maximum of 2 possible solutions. You could have less. You could have one solution. You could have no solutions. But at most, the maximum you could have is 2. In order to solve quadratic equations, first, make sure you put the quadratic form in this standard form. In other words, set it equal to 0. Then factor the left-hand side, and then use what's called the zero product property. The zero product property basically says that if you have two things being multiplied to each other, and you know that the product or the answer of this multiplication problem is 0, the only way to get 0 is if either the first number is 0 or the second number is 0. That is the only way to get 0 as an answer from a product, is if either the first number or the second number, or they both could be. But 0 has to be in at least one of those spots. We're going to use that to our advantage to solve some of these equations. To solve this first one, they suggest you use factoring. So we already have it set equal to 0, so the first step is done. Now we move on to factoring. Everything on the left-hand side does have a greatest common factor, so I'm going to pull the x out. Now you'll see that I actually have a product on the left-hand side. There is a multiplication symbol right here that is invisible, so I have x times x minus 4, which is equal to 0. So that means either x is equal to 0 or x minus 4 is equal to 0. In order for that product to be 0, one of these two components must be 0 itself. Well, I've already solved for this x over here. To solve for this x, we're going to add 4 to both sides, and that's your second solution. Of course, we would check these. Always check your answers. So we're going to go back up to the original and ask ourselves, is 0 squared minus 4 times 0 in fact equal to 0? Yes, it is. Is 4 squared minus 4 times 4 in fact equal to 0? And yes, it is. So these are in our solution. Next one. X squared equals 6 minus x. Again, the first step is to put it in standard form. In other words, set it equal to 0. I suggest always move things to the side that will make this squared term positive. So I'm going to pick the left side and move everything over to here. So I'm going to subtract the 6 and add this x, so that way I have 0 on the right-hand side. So make sure on this side we subtract 6 and also add x. So that gives me x squared plus x minus 6 equals 0. Now I'm going to factor. Using the tools that we learned back in R.5, we're going to factor this left-hand side. Recall, x times x is x squared. I need two numbers that multiply to make 6, but they have to add up to positive 1. So this would be the factored form. Now, using the zero product property, that means either this is equal to 0 or this is equal to 0. So I have two answers, one at -3 and one at 2. Let's check. -3 squared, is that in fact 6 minus -3? 9 equals 6 plus 3? Yes. Let's try 2. 2 squared equals 6 minus 2. Is 4 equal to 4? Yes. So they both check. Next one. Let's distribute. Let's get rid of parentheses, because remember we want it to look like it's in standard form. There are no parentheses in standard form. So let's get rid of those parentheses. So distribute. We have 4u squared minus 8u plus 3 equals 0. Let's factor. Back in section R.5, we talked about using the A times C method. If you do that, you'll find that the factored form is 2u minus 1 and 2u minus 3. So we set both of these pieces that are being multiplied together equal to 0. So either 2u minus 1 is 0, or 2u minus 3 is 0. So I have two possible answers. To check, let's plug them in. 2 times 2 times 1/2 squared minus 4 times 1/2 plus 3. Is that in fact equal to 0? Let's check it out. Two times 1/2 squared minus 4 times 1/2 plus 3. 0. Does work. Let's try the other one. 2 times 3/2 squared minus 4 times 3/2 plus 3. Two times 3/2 squared minus 4 times 3/2 plus 3 equals 0. So they both check out. So these are indeed the answers. Another way to solve quadratics is to use what's called the square root method. If you have x squared equals to a number, in other words, there's no middle term, you're going to have something like x squared equals 16. There's no middle term. There's no, plus 4x or some other middle term in there. If there's no middle term, the square root method is the easiest to use. So in other words, there's no bx term. So if you have this, the square root method is the way to go. Since you have x squared equals to some constant number, then you could say x equals the square root of that number. In other words, you take the square root of both sides. When you take the square root of a square, they cancel each other out because they're inverses. So you're left with x equals the square root of 16. But don't forget, you always have a plus and a negative version of that answer, because negative 4 squared is also 16, as well as positive 4 squared. So you'll always have two answers. That was just one example. Let's look at the examples on the lecture notes. Here we have x squared equals 7. So you have x squared equals a constant. In other words, there is no middle term. So I'm going to take the square root of both sides. That square root will undo the square, so you're left with x equals square root of 7. Well, that's an irrational number, so we cannot simplify that. So we're going to simply leave it as square root of 7. You're going to have a positive square root of 7 and a negative square root of 7. So there are actually two answers. Never approximate these. Don't put these into your calculator and find an approximated decimal unless the homework asked you to do so. The next one, we have something squared minus 9 equals 0. There are two ways to do this. One way is to FOIL all of this out. This is the long way, but I'll show you. Actually, I'll put it on a separate piece of paper because I probably won't have enough room. Okay, so if I wanted to FOIL all of this out, I would have x plus 3 times x plus 3 minus 9 equals 0. So when I FOIL, I have x squared plus 6x plus 9 minus 9 equals 0. You'll see that those cancel out. So I'm left with x squared plus 6x equals 0. Now, according to the first step on number 1 of the lecture notes, you want to factor. So if I pull that x out, I'm left with x times x plus 6 equals 0. So I set both of these parts equal to 0 using the zero product property. So either x is 0 or x plus 6 is 0, meaning x is negative 6. So I get two answers, one at 0 and one at negative 6. But there's actually another way to do this problem that would make it simpler and maybe shorter steps. What I'm going to recommend we do is we use the methods that we've learned already, which is the square root property. If we set this left side equal to the constant, in other words, move the negative 9 to the other side, it looks very similar to the last question, where you have something squared equals a constant. I do have something squared. It just so happens that the something is more than just one term, but that's okay. I can still solve this like I did the square root property. I can take the square root of both sides at this point, and you'll see that this square root will inverse and undo the squared symbol. So I'm left with x plus 3 equals plus or minus what the square root of 9, which is 3. So I have to solve this. There's actually two equations from here. The first equation is x plus 3 equals the positive 3 on the right side, and then I'll also have x plus 3 equals the negative 3 on this right side. So if I solve both of these, I subtract 3 from both sides, subtract 3 from both sides, and you'll see I'll get the exact same two answers that I did when I FOILed it all out down here. So both methods will work. Depends on which one you like. The square root method probably will be a little shorter steps, but the FOIL method does seem to be sometimes the preferred method of some students because they're used to distributing everything out. The third method for solving quadratic equations is using the quadratic formula. The quadratic formula will work for every single problem. So if you don't like the first or the second method we already taught you in the last 15 minutes, the quadratic formula will work for every single problem all the time. So if you want to just start with the quadratic formula, you can, because it will work. The first two were just shorter ways to do it if you can see that they will work. Now the quadratic formula is something you'll have to memorize. So in order to use the quadratic formula, it's probably something you might want to consider memorizing. But this is a very, very common algebraic formula that is something that's very important. Now there's a few rules that we want to consider when we use the quadratic formula. The first thing you're going to want to do is put the quadratic equation in standard form. That's something we're used to doing already. Then identify what A, B, and C are. Those are the coefficients of the three terms of the quadratic. Then find the discriminant. The discriminant is b squared minus 4ac. That's everything that's underneath this square root symbol. The discriminant is important because if it's positive, you'll have two real solutions. So if this discriminant is positive, you'll have two real solutions. If you get 0 underneath this discriminant, then you'll only have one solution. There will only be one repeated solution. We'll talk about multiplicity in a future section. If the discriminant is negative, that means you'll have a negative number underneath this square root symbol. And as I stated earlier, you cannot have a negative underneath a square root symbol because you can't take the square root of a negative number. There is no real solution if you get a negative underneath here. Now you do have what are called imaginary solutions, but we won't get to those until the next section. For now, all we can say is there are no real solutions if you get a negative underneath the square root symbol. So we're going to go through some examples down here and just determine what the discriminants are so we can decide how many solutions we might have. We're not actually going to solve them just yet. Okay? For this equation below, find the discriminant and say how many solutions there are. So I've already got this in standard form. So this is my A, this is my B, and this is my C. A, B, and C. The x's are not part of the A, B, and C, only the coefficients in front. So now what I'm going to do is I'm going to find the discriminant. I'm going to figure out what b squared minus 4ac is. B squared minus 4ac. Well, that's equal to b is negative 4. So negative 4 squared minus 4 times a, which is 2, times c, which is 1. 16 minus 8 is 8. Clearly 8 is a positive number. It is, in fact, greater than 0. So when you get a positive discriminant, a number that's greater than 0, you're going to have two unequal real solutions. So now it says if a solution exists, which it does, there will be two of them, go ahead and use this quadratic formula to solve. So we're going to use this quadratic formula to solve. So we're going to have x equals negative b, so in this case it's going to be negative of negative 4. So that's going to turn into a positive. Plus or minus the square root of, under here is the discriminant. We don't have to calculate all of this all over again. We already found the discriminant down here. It's 8. All over 2 times a. So 2 times a, which is 2. So let's simplify. Negative negative is actually positive, plus or minus square root of 8 over 4. Now we're going to want to simplify this. You should be able to simplify radicals. Excuse me. You should be able to simplify radicals. The square root of 8 can be simplified into square root of 4 times 2. Well, the square root of 4 is a whole number. It's a perfect square. It's 2, so we can pull that out in front. So let's take the square root of 4 out in front and make it 2. Then you can factor out the greatest common factor here, which would be 2. So I'll take that 2 out, and that leaves me with 2 plus or minus 1 square root of 2 over 4. By doing that, you'll see that there is something I can reduce at this point. The 2 and the 4 can be reduced, so I have 2 answers. The 2 answers that I will have here are going to be x equals 2 plus square root of 2 and 2 minus square root of 2. So those are going to be my 2 answers. So in your homework, you'll have to type both of them in with a comma in between. Oh, excuse me, over 2. Don't forget about that 2. I almost forgot about that 2 down here. So these are your answers. All right, let's try some more. Let's first decide what the discriminant is of this quadratic equation. It's already in standard form, a, b, and c, so the discriminant is b squared minus 4ac. So b squared is going to be negative 6 squared minus 4 times a times c. So the discriminant is 36 minus 4 times 1/2 is 2, and 2 times 18 is 36. So the discriminant is 0. When the discriminant is 0, according to what we discussed earlier, when the discriminant is 0, that means you have a repeated solution, just one repeated solution. So that means we have one solution. So let's go ahead and solve. X equals negative b. Negative b would be negative of negative 6, plus or minus the square root of the discriminant, which is 0, all over 2 times a. So this is negative negative, which is 6, plus 0, over 2 times 1/2, which is 1. So we have one solution, and the solution is 6. Of course you can check these. I plug 6 in, so what's 1/2 times 6 squared minus 6 times 6 plus 18? So 1/2 times 6 squared minus 6 times 6 plus 18. In fact, you do get 0. So this is my answer. Let's find the discriminant. The discriminant is b squared minus 4ac. Oh, I didn't put it in standard form, did I? All right, put this in standard form first. So we got to move that 2x over here to make a middle term. So it becomes 2x squared minus 2x plus 3 equals 0. Now I know what b is. b is negative 2. So negative 2 squared minus 4 times a times c. So my discriminant is 4 minus 8 times 3 is 24, and the discriminant is negative 20. According to the first page, when the discriminant is equal to, or excuse me, less than 0, there is no real solution, because that means everything underneath the square root symbol is negative, and we know you cannot take the square root of a negative number. So if I were to go ahead and do the quadratic formula, you would get x equals negative b plus or minus the square root of everything underneath the square root is going to be negative 20 over 2 times a. So you can see when I put this in my quadratic formula, you're going to get a negative, that discriminant underneath here. And you can't take the square root of a negative number. So this means there are no real solutions. So we've done 3 types so far. On the first page, we did an example where the discriminant was positive. That gave me 2 real answers. Then we did an example, Then we did an example where the discriminant was 0. When the discriminant is 0, it gives you 1 real answer. Now we did an example where the discriminant is negative. When the discriminant is negative, that gives you no real solutions, or the empty set. Okay, so let's do another one now that we've done one of all 3 types. This one's a little trickier because we have x's in the denominator. So let's recall back to what we did when we have x's in the denominator. We want to get rid of all fractions. So I'm going to multiply both sides of this equation by something that will get rid of those denominators. In this case, x squared will get rid of those denominators. So when I multiply x squared times all 3 terms, you're going to get 6 times x squared, 1 times x squared, 2 times x squared, 0 times x squared. You'll see that some of these x's will cancel. One of these x's will cancel with one of these x's. Both of these x's will cancel with both of those x's. So we're left with 6x squared plus 1x minus 2 equals 0. This is in standard form. Now we can determine what a, b, and c are so we can find our discriminant. So the discriminant is b squared minus 4ac, which is going to be 1 squared minus 4 times 6 times negative 2, which is 1. Negative 4 times 6 is negative 24 times negative 22 is positive 48. So the discriminant is 49. According to our rules, when you have a positive discriminant, that means you have 2 real solutions. So let's go ahead and find what those solutions actually are. So x equals negative b. So we're using this as our standard form. So negative b is going to be negative 1 plus or minus the square root of the discriminant, which is 49, all over 2 times a, which is 6. So we have negative 1 plus or minus, square root of 49 is 7, all over 12. So we actually have 2 answers. We're going to have one answer, which is going to be located at negative 1 plus 7 over 12, and then another answer at negative 1 minus 7 over 12. So our first answer will be at 6/12, which is 1/2, and our other one will be at negative 8/12, which is negative 2/3. So we have 2 answers, 2 real solutions, and they're going to be located at 1/2 and negative 2/3. So I would write those, the proper way to write those would be to say x equals 1/2 and -2/3. Of course, we can check those. Since I ran out of room, I'll do it on a separate piece of paper. So let's check those. They're over here. Okay. I'm going to go back up to the original equation and plug these two answers in. So the original equation up here says 6 plus 1 over x. Well, we know our two solutions. Our two solutions were 1/2 we're going to check that one, but then we're also going to check to see if -2/3 is also a solution. So we're going to check both of these. And I could put those into my calculator. So let's see. The first one we have here on the left-hand side is 6 plus 1 divided by 1/2 minus 2 divided by 1/2 squared equals 0. So this one does in fact check. Let's check this one over here. So I have 6 plus 1 divided by -2/3 minus 2 divided by -2/3 squared equals, and again, you get 0. So both of those answers do in fact check out. All right, on to the last question. It's an application problem. And the application says that a ball is thrown vertically upward from the top of a building 96 feet tall with an initial velocity of 80 feet per second. The distance s in feet of the ball above the ground after t seconds is s equals 96 plus 80t minus 16t squared. Okay? So the first thing I would recommend you do is rewrite the equation in standard form. So this is not in standard form. I would recommend writing this in standard form. So let's put the t squared first. Okay? Now it says draw a picture. So we know that this ball is being thrown vertically upward from the top of a building. So I'm going to draw a building. Okay? And someone is standing at the top of this building and throwing this ball vertically upward. So we have this ball which is red. There's my ball. And you're throwing this vertically upward, up to the sky. Okay? The building is 96 feet tall. So this building here is 96 feet tall. And when we throw this ball up in the air, we're throwing it at an initial velocity of 80 feet per second. Now all of this information is extra because it actually already put it into the formula. So you didn't have to construct a formula. All of that information has already been constructed for you into this quadratic formula. This is the velocity and this is the initial height of the building. So all of this information here you didn't necessarily need because it's already been constructed here. So all we really need is the formula. The distance s in feet that the ball is above the ground after t seconds. So s, once this ball goes up, it's obviously at some point going to start coming back down, right? And s is the distance in feet that the ball is above the ground at any particular time in t. So s is in feet above ground. T is the time. So at initial time 0 is when the ball's still in your hand. And after a certain amount of time has expelled, S is going to get bigger, 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 and then it's going to start getting smaller, smaller, smaller again until it hits the ground. So let's answer the questions. When the ball hits the ground, the distance above the ground is obviously 0 feet. So that means S is 0. Because when the ball goes up and comes back down, and the ball is now laying on the ground, S is 0. It's the distance above the ground. So S is 0. After how many seconds does the ball hit the ground? So if S is 0, we're going to plug 0 into S up here and solve. So if S is 0, we have 0 equals negative 16t squared plus 80t plus 96. Now how do we solve this? If we go back to the original, at the very beginning of this section, there were two methods we could try first. Of course the quadratic formula will work, but there are two other methods we could try first to save some time if you chose to. You could put this in standard form and use the zero product property by factoring. I'm going to try that first and see if that might help. So I'm going to try to factor this. I see that all these numbers are divisible by some number. I'm not sure what that is. I'm going to try something big. I'm going to try 16. I know this is divisible by 16. Is 80 divisible by 16? It is. Is 96 divisible by 16? It is. So I actually can take a 16 out and I'll be left with a pretty easy trinomial to factor. But in fact, I'm actually going to take out a negative 16 because remember I told you it's always easier to factor if your first term is positive. So this is plus 5t plus 6. So let's keep factoring. I need two numbers that multiply to make 6, but those two numbers have to add up to 5. So the answers are 2 and 3. So that means, since the answers are 2 and 3, that means either t plus 2 is 0, or t plus 3 is 0. Oh, I goofed up. Let me go back. When I take out that negative 16 right here, I didn't change the signs inside. I knew something didn't seem right. When I take out a negative 16, it's negative 16 times negative 5t, negative 16 times negative 6. That's going to give me positive 96. So my apologies, I have to go back to that point there. Alright, so that's going to change. Alright, let's keep going from this point. Okay, now that we have the correct signs, we have negative 16 equals t squared minus 5t minus 6. So that is factorable. Two numbers that multiply to make negative 6, but add up to negative 5. Let's see, that would probably be 3 and 2. No. How about 6 and 1? Yes, negative 6 and positive 1. Negative 6t plus 1t is negative 5t. Okay, so we have found our factored form. So that means either t plus 1 is 0 or t minus 6 is 0. If I subtract 1, t is negative 1 or t is 6. Now, the question was, how many seconds till the ball hits the ground? T is in seconds. So when that ball goes up, when that ball is going up, up, it says after -1 second, that ball hits the ground. Well, that's impossible. You cannot have a negative time. So in this case, this is not an answer because it doesn't make any sense. T has to be positive. This is the only possible answer that will make sense in the context of this application. So sometimes with word problems, you have to check to make sure both of these will work in the problem. Time cannot be negative, distance cannot be negative. One other way we could have done this question is we could have used the quadratic formula if you chose to do so. If I would have done that here, I wouldn't have made this mistake, see? So if I go back to this original and use the quadratic formula, I'll do it right here. The quadratic formula says negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to need my calculator's help on this one. All right, so what is my discriminant? My discriminant is going to be 80 squared minus 4 times -16 times 96, and your discriminant is 12,544 divided by -32. The square root of 12,544 is 112. So it's -80 plus or minus 112 over -32. There will be two answers. There will be one answer at -80 plus 112 over -32, and another answer at -80 minus 112 over -32. So -80 plus 112 is 32. Well, that's -1. Over here, -80 minus 112 is -192 divided by -32 is 6. So you can see that we get the exact same two answers that we did on the previous page using factoring. So at this point, it's up to you to decide which method you like better, whether you like to do the factoring method. If you're good at factoring, you'll probably find these answers you'll come to faster, but there is room for error if you factor incorrectly. Then there's also the quadratic formula. If you use the quadratic formula, you get to the exact same two answers. So you have your choice.